Okay, people should start entering.
Okay.
Just ask you to
Welcome, everyone. We'll just ask if everyone can put themselves on mute and we will get started in a minute. Good afternoon, everyone. We will be starting in a minute. Please feel free to add anything into chat. We would like to see the engagement today. Any comments or questions, I will be reviewing them to make sure that our speaker, Andrew, can read them. And Michael just posted a little thing in chat right now. And we'll just give one more minute before we start. Oh, that looks like got a lot of people here. Okay, good afternoon, everyone. My name is Tricinda Davis. I am the NEHA Technical Advisor for Food Safety. I'm really happy to present this presentation today. I read this abstract and it was very, very interesting. The title is Insights and Learnings from Applying Big Data and AI Technologies to Regulatory Food Safety Data on a National Scale. Our speaker is Andrew Harrison. He's the Chief Technology Officer of Hazel Analytics. And again, if you didn't hear me before, please, we'd love to see your engagement. Feel free to put questions and comments in chat. Andrew's going to be addressing some of the questions in about the middle of the presentation as well as at the end. So we just like to encourage that. So after further ado, take it away, Andrew.
Thank you so much, Tricinda. I'm really pleased to have the opportunity to speak to everyone today. Just by way of a little bit of background, Hazel Analytics is the leading company for data analytics regarding food safety and compliance for food retail and service sectors. Our mission is to improve public health through data-driven technology that effectively informs and connects food service operators, consumers, regulators, and industry providers. We are based out of Seattle, and we've been steadily growing over the past 6.5 years since our company was founded. Our primary customer base consists of regional and national food retail brands. This is quick service restaurants, casual dining concepts, and groceries in particular, but also convenience stores, hotels, and more. Our technology is used by more than 240 brands with a collective footprint in more than 300,000 locations. We service 2 of the top 3 food retail chains and more than half of the top 100. So increasingly, we're also working with industry stakeholders in other areas. That includes food delivery and restaurant review websites. Today, I'd like to share Hazel's perspective on regulatory food safety inspections with you, starting with an overview of the digital data landscape for publicly reported inspections, then proceeding to some observations about characteristics of the data which emerge from analysis at scale and the application of machine learning techniques, including routine inspection frequency, the prevalence of violations, and inspection scoring. Finally, I'll conclude with some of our takeaways, underscoring the need for great digital data, discussing performance indicators in the context of the industry, and looking at the path ahead. So without any further ado, let's dive into the digital data landscape. To establish a sense of scale, Hazel Analytics collects data from hundreds of health agencies in the US around the clock. Our coverage includes 95% of everything that's digitally available, and that translates to roughly 75 to 80% of the country's population. We also have a strong footprint in Canada and the UK, but today's discussion will just center on US data. In 2019, we collected roughly 2.5 million inspections, performed at roughly 1.5 million locations. The 2020 numbers are slightly lower due to the impacts of the pandemic on inspections and reporting, but we still covered in excess of 1 million locations. The scope of data we collect extends beyond just our customers' facilities because we aim to have as complete a collection of health inspection data as possible. We focus on digital online data for two reasons. For one, published data online is highly effective for agencies and convenient for those who need the data. When an agency publishes health inspection data online, that report can be accessed by anyone without further need for agency personnel to get involved and at a minuscule cost. Contrast this push method with the pull method of public records requests. Although records requests are technically available, they can be seen as a barrier to entry for many. Moreover, the person making that request has the downside of information asymmetry. They may not even know whether the data they're looking for, such as a new inspection report, is available yet. If they make a request for a report that doesn't exist, they're wasting their time and the agency's time. And when the report does exist, the requester may not get a response as soon as they'd like. So in short, public records requests put the onus on the requester to take an interest in the first place, risk having their time wasted, and be comfortable with not having an immediate answer. Proactive publication of digital data can eliminate or reduce these pain points. A second reason is that manual collection of data via records requests doesn't scale well, whether for benchmarking, trend analysis, or the development of new technology. A complete data set is often a necessity. In addition, requiring each person or company who consumes this data to perform their own transcription can cause costs to balloon and increases the risk of errors. When an agency delivers a well-organized digital asset up front, these costs are greatly reduced. There are challenges involved in digitization on the agency side, of course, but I would argue that the benefits derived from better data merit these costs. We need data reporting to work at scale because a large-scale understanding of food safety data is vital for guiding public policy, setting industry expectations, and establishing advances in technology. We're happy to say that as of January 2020, when the city of Minneapolis launched their online portal for public health inspections, there is at least some amount of digital data coverage in all 50 states and DC. In many cases, this data is available statewide, but that's not universally true. As with so many technological advances, improvements don't all happen at once. This quote from the science fiction writer William Gibson, "The future is already here, it's just not very evenly distributed," certainly applies to the world of health inspection data. To dig into that idea a bit further, I'll present a few maps describing how different levels of detail are reported in each state. In addition to the question of whether any inspection data is available, we'll examine whether reports include high-level characteristics, such as an inspection's overall score or grade, and the type of inspection performed, as well as violation level details, the level of severity, specific remarks on findings, and indications of whether a violation was corrected on site or a repeat violation. I should caveat the following slides just to acknowledge that the data landscape changes often and with surprisingly little fanfare, so there may be some small discrepancies despite our best efforts. And in particular, we recognize that COVID has impacted how inspections are both conducted and reported. This map shows the extent of online availability for inspection records in each state. The darkest green color, applied to 23 states counting DC, indicates that records are published for all facilities throughout a state. Typically, a state-level agency is coordinating all data publication, or the responsibility is split between two state-level agencies, such as Florida's Department of Business and Professional Regulation and Department of Agriculture and Consumer Services, or a state-level agency covers most areas, but separate regions and metro areas host their own reports. The second darkest green, which you can see in several West Coast states and mountain states, accounts for another 19 states, those with majority but not complete coverage. Offline carve-outs for a region or one or two metro areas can result in this nearly complete data availability. Next, there are two lighter shades of green. Indiana, West Virginia, Maryland, and New Jersey are areas of minority coverage. A few regions or metros may be online, but most of the state is still offline. Finally, Minnesota, New Mexico, Connecticut, Massachusetts, and Maine are the 5 states with a sparse digital data presence, usually only 1 or 2 metro areas. Personally, I would be very happy if we got this map to be a solid dark green coast to coast over the next 4 years, but even for states that do publish reports online, there can be meaningful variation as we dig into the details. To show a really stark contrast, the availability of inspection scores varies quite a bit. 14 states in dark green include a numeric score, a letter grade, or some other overall indicator in their reports consistently. In another 23 states in light green, the availability of a score or grade depends on how local agencies conduct inspections or publish reports. This leaves another 14 states where the published reports never include this indicator. There's a similar story in terms of reporting the type of inspection performed. Here, I'm focusing on complaint-initiated inspections. On the whole, these are less commonly listed than follow-up inspections and more common than pre-opening inspections or other types. 14 states in dark green do call out complaints systematically. These aren't the same 14 as on the previous slide. In lighter green, 27 have inconsistent reporting on complaint-initiated inspections, and 10 states rarely or never indicate complaints. Changing gears to violation-related specifics, we see that violation line items are almost always included in reports, which is great news. It's only in 11 states that the availability of violation line items depends on jurisdictional practices. New Hampshire, highlighted in blue, is a special case. It's the only one where its online jurisdictions only report critical violations. One of the most valuable details for our customers is an indication of violation severity. Whether an agency is using the FBI GRP nomenclature, Priority Foundation Core, or some other terminology, it's useful to establish that sense of impact and urgency. There are only 4 states, New Mexico, Kentucky, Mississippi, and Virginia, where online jurisdictions aren't including this detail directly in a published report. It may be discoverable in a separate document that outlines a local food code in more detail, or something that Hazel systems can infer based on point value deductions, but an explicit indicator that's part of the report itself is really what we prefer to see. Also highly valued by our customers are specific details on each finding. We're looking for something more than an alphanumeric code. At minimum, it should be a meaningful description of the violation type, but specific commentary from the inspector that pinpoints problems is even better. If you're citing a violation for unclean surfaces, it makes a difference to our industry customers, whether you're seeing gunk on the ice machine, the soda nozzles, or the salad bar. It's a little bit tricky to condense the spectrum of levels of detail into just a few categories, but I'd say that Mississippi and Delaware's online records lag slightly behind in this respect, although several states may not be particularly consistent about the level of detail provided. I won't spend much time on corrected on-site or repeat violations, except to say that their availability is even less common than violation severity or descriptions. The COS annotations can be a big help to industry brands that monitor food safety risks holistically, since it helps them better understand which problems might still be ongoing and in need of support. While annotations for repeat violations highlight facilities where retraining or a better root cause solution may be needed. There's a lot more that we could say on the digital data landscape, but we don't have time for everything. One more data point I would like to highlight is the lag time between the date of an inspection visit and the date when it's published online. Close to half of all reporting jurisdictions post their reports online in under 48 hours, which is a huge benefit to industry operators. And 80% of jurisdictions post reports in under a week. However, there are some jurisdictions that have a consistently lengthy delay between these 2 dates, especially jurisdictions that wait to compile everything into a monthly report. These delays can reduce the ability for a corporate food safety team to take action and intervene. In these areas, a facility could undergo 1 or even 2 re-inspections before word gets back to headquarters. Reducing this lag time can allow for faster support, which means fewer re-inspections, which means less demand on agency resources. Some of the other aspects of digital reporting, which we consider at Hazel, include different digital formats, the user experience of online portals, whether and how closures are reported, and data quality concerns generally. Towards the end of the talk, I'll provide a link to a white paper that Hazel Analytics has produced, which covers a lot of this material. Are there any questions so far?
Not so far, Andrew.
In that case, we'll move straight on to some of the insights that we can get from this data. We can ask a lot of questions about the data set that we have, but today I'll center on 4 areas that are approachable but important. First, the frequency of routine inspections. Second, the prevalence of particular kinds of violations. Third, the number of violations that are typically cited per inspection. And lastly, the distribution of inspection scores. Looks like we may have gotten, yes, I appreciate the chiming in from Douglas County, Nebraska. We do hope to see improvements in lag time really across the board. I would love to dive deeper into that, Elizabeth, if you want to connect later. So we'll take a look through each of these 4 sets of observations. We'll talk about the data first, and then have a brief mention for practical impacts. Let's start with routine inspection frequency. In this chart, the x-axis is showing the median number of months between routine inspections, and the y-axis is the number of states with that interval. The 2 peaks in this chart suggest 2 groups of states. Those that more typically inspect their facilities twice per year on the left, and those that more typically inspect once per year on the right. This is roughly 35 states in the semi-annual group and 16 in the annual group. The actual policies in each state may be more nuanced, stipulating different schedules for different risk classifications, but what we're looking for is the actual inspection frequency for a typical facility. States that have more aggressive schedules on paper, yet fall into that latter group for median inspection frequency, either don't categorize many facilities in their higher risk tiers, or aren't able to adhere to their desired schedules in practice. In this chart, we're looking at the 90th percentile of routine inspections. That means the x-axis shows the interval between routine inspections, which covers 90% of a jurisdiction's data. Another way to think of this is, what's the approximate upper bound of routine inspection frequency, excluding the slowest 10%, which could be extreme outliers. 13 states managed to keep their 90th percentile frequency at or under 12 months. So the vast majority of facilities are successfully inspected on at least an annual basis here. 26 states have a 90th percentile frequency between 12 and 18 months. This suggests that it's not terribly rare for a facility to be passed over for inspection within a given calendar year. And the remaining 12 states have a very long interval between routine inspections at the upper end of their frequency distributions. Further evaluation is needed, but this could be attributed to gaps in enforcement, insufficient resources to meet policy expectations, or incomplete public reporting. The knowledge of observed inspection frequency can be used for review purposes. In cases where records requests need to be made to health departments, this metric can give industry stakeholders a better sense of when to expect data availability, lowering the odds of an unproductive agency interaction. At Hazel, we could filter this further for our customers down to their specific brands so they've got an even more precise timeframe. Routine inspection scheduling can also be used to inform investigations into the question of equity in enforcement. It's also a step towards an ability to forecast upcoming routine inspections. If we're able to predict that a routine inspection could occur soon, without being so specific that the surprise nature of an inspection is undermined, we may be able to prompt businesses to engage in preemptive remediation. We see this scenario as a win-win in that consumer risk can be diminished sooner, Businesses are rewarded for proactive food safety engagement and fewer inspection visits if needed. Next, we're turning to violation data. In order to make more sense of this data, which is highly variable when looking at locally defined terminology and codes, we've developed a new machine learning model that allows us to harmonize violations against the 2017 FDA Food Codes model inspection form, using as input both standardized labels and violation-specific inspector comments. The current level of accuracy is quite good, and from some of the model evaluation that we've done, we know that some of the confounds include garbled text and cases where remarks on multiple unrelated violations are bundled into a single line item. When the input is reasonably well formed, the accuracy is even higher. And the model also recognizes certain types of violations that are fairly common at the state and local level, but not defined in Form 3B, such as placard posting and hepatitis A immunization methods. Applying this model to 2019 and 2020 data, we find that just 7 violation types account for nearly half of all violations in our data set. Physical facility cleanliness violations account for more than 10%, and 3 entries pertaining to food and non-food contact surfaces collectively account for more than 20% of all violations. Looking at a breakdown by state, we find that most states have at least one violation type that accounts for 10% of their observed violations or more. So Alaska has 2 violation types at 10% or more, Alabama has 1, and so forth. 11 states have a 0 in this table, indicating a comparatively more even distribution. There's no single violation type that exceeds 10%, while Delaware, Mississippi, New Hampshire, Nevada, and South Dakota are the outliers with 3 or more violation types that exceed 10%. In other words, just 3 types of violations make up nearly a third of all violations reported in these states. Usually, each state's top violations are roughly in line with the national trend, but we have identified a few exceptional cases. In Alaska, there's an outsized rate of certified food protection manager violations. In Kansas, date marking and toxic substance storage top the charts. Mississippi and New Hampshire have elevated rates for item 15, food separated and protected, and New Hampshire has 2 other items. And finally, New York has an atypically high rate of vermin citations. New Hampshire, as I mentioned earlier, is a little bit exceptional since we aren't able to factor in non-critical violations that are not digitally reported. When we add in the nationally prevalent violation types again, we can see that there are even a few cases in Delaware, Mississippi, New Hampshire, and Vermont where the prevalence tops 20%. We interpret this as a clear sign that a concerted effort at intervention is needed, which, if successful, could lower overall figures for non-compliance significantly. When we see hotspots or trends in violation type data, it underscores the need for systematic changes in training and education. By creating awareness of the scale of each problem, we can subsequently create opportunities for research, public policy initiatives, and innovation in the industry. A slightly different view on violation data examines the question of how many violations are cited in a typical routine inspection. Looking at pre-COVID data, the national median is 2 violations per routine inspection, and the 90th percentile is 8, meaning that 8 violations is close to the upper end of what you might commonly see. Evaluating this metric on a state-by-state basis, we found that the 8 states listed here have historically had higher per inspection rates of violations. Also, Indiana and Pennsylvania matched the median value, but they had much higher 90th percentile rates, meaning that their inspections have a higher upper limit and more variance. The other end of the spectrum is also interesting. The 8 states listed here had a median violation rate of 0, which could either indicate stellar food safety compliance or suggest that there's some jurisdictional leniency at play. My home state of Mississippi in particular has somewhat suspect numbers. I want to emphasize that these are states where we have a significant degree of data coverage. So this isn't an effect of cherry picking the inspections. We can also look at per inspection violation rates through the lens of violation criticality, not including any states where we have lower digital coverage or where violation criticality isn't reported. The states listed here have a median value of 1 critical violation per inspection, FBI, priority, whichever terminology applies locally. It's practically a coin toss whether a critical violation will be cited. In our view, this level of frequency for critical violations should be a call to action. Similar to the violation prevalence stats, we believe that the data on per inspection violation rates can inform education and training initiatives. It can also motivate conversations about jurisdictional leniency and the importance of public reporting. And stakeholders on the industry side need to understand these figures in order to better calibrate expectations and define the right language to frame further analysis or create alerting processes with sufficient context. In this area in particular, attribution is a thorny issue. Is food safety compliance legitimately higher in some areas than others? Are enforcement patterns responsible for major differences? Are inaccuracies in reported data to blame? It seems unlikely that actual compliance levels vary quite so markedly. We don't have conclusive data to back that statement up, but we do see similar effects playing out within states at the neighboring county or city level. So greater or lesser leniency does appear to be a contributing factor. Issues in the underlying data are also a contributing factor. We work to reduce that as much as possible, but limitations at the data source can be challenging to work past. Just to highlight one example, I found a recent inspection report from an Irish pub in my hometown of Jackson, Mississippi. It was given a C grade, putting it in the bottom 15% or so of all routine inspections, but only 1 violation was cited as not in compliance. And the sum total of violation counts is not consistent with the observed line, the 2 empty columns being for COS and repeat violations. So it's difficult for us to say just how much reporting inaccuracy skews these violation figures, but over time, as reporting practices improve, this effect should hopefully diminish. In that last slide, I noted that a C in Mississippi would put a facility in the bottom 15% of routine inspections. Score distributions are an area that Hazel has devoted quite a bit of attention to. Skewed scores were a focus of some of our early academic work behind the company, and our website's research page links to several papers on that topic. Our founding team's research has shown that inspection scores can have a positive impact on food safety performance, but when the audience for inspection scores changes from consumers who may be more familiar with their local agency's rating system to major corporate brands who operate across jurisdictional boundaries, there are challenges in using scores as a performance indicator. Different agencies utilize different scoring terminology. We can't assume direct equivalence. An A in New York City may not mean the same thing as an A in Los Angeles County. And it may not be entirely obvious how strong a signal each score sends. That is, how much does a particular score indicate a well-defined level of compliance or non-compliance? There's a lot of information that we could unpack regarding scores. To me, one of the more interesting ways to look at scores is to consider the proportion of inspections that receive a top rating. In a 100-point system, this would be a 100 out of 100. In a letter grade system, this is an A, and so forth. When we compare these different scoring systems, we can see how much variability there might be even for these top scores. The y-axis here is the percentage of routine inspections that are receiving the given top score in a jurisdiction. The dark bar across the middle of each colored segment represents the median percentage. The colored segment shows the quartiles around the median, and the thin bars at the end show minimum and maximum observed values. So to read out a summary of this chart, jurisdictions with 100-point scoring systems tend to award 100-point inspection scores between 10 and 30% of the time, which is fairly reasonable considering that any items marked out of compliance will usually result in a point deduction. However, we've seen jurisdictions awarding a perfect score to fewer than 2% of all inspections and nearly 70% of all inspections. So this type of scoring isn't necessarily as cut and dry as you might expect. I have also broken out the demerit-based jurisdictions. Functionally, these are the same as 100-point systems. The only difference is that they add points per violation and a 0 score is perfect. As it turns out, their distribution is not all that much different in practice, but the median is a little bit higher. There are fewer of these types of jurisdictions to base the measurement on in the first place. Finally, that brings us to the categorical scoring systems, your letter grades, pass, fail, red, yellow, green, and so forth. Here we see tremendous variability, from 7% to 99% of routine inspections over this period receiving an A, pass, green, or whichever category is the best grade in that jurisdiction. Half of the jurisdictions that use categorical labels commonly assign their top score to 45% to 90% of all routine inspections. And because the selection of which scoring system is in effect doesn't really have any correlation to their physical location or anything of that nature, there's no apparent correlation with size or the number of facilities that are overseen. The differences for top scores don't end there either. These paired charts show distributions of violations. On the left, the total number of violations that could be cited in a top scored inspection, and on the right, the number of critical violations that could be cited. The exact numbers aren't really necessary to focus on here, but if the meanings of top scores were equivalent across jurisdictions, we might expect these charts to look quite similar. Instead, we're seeing rather different distributions of violation counts. In New York City, almost all A-rated routine inspections have 3 or fewer total violations. While in Los Angeles County, it's not uncommon for an A-rated inspection, a routine one, to contain 6 to 8 violations. And a green rating in Hawaii turns out to be far more strict than any of these in terms of violation counts. This is really only the tip of the iceberg when it comes to looking at how scores are applied to inspections. To be clear, we believe that scores are a valuable tool for informed consumer choice and incentivizing strong compliance in the industry. However, the sort of variability we see when looking at the scoring data nationwide makes it difficult to use them for broader benchmarking, orienting corporate food safety policies, and communicating to consumers in cross-jurisdictional contexts. In fact, for Hazel's own customers, we use our own standardized percentile-based scoring system to better differentiate top and bottom performers. We could argue that the variability is also a minor concern for consumer education, since the general public may not have enough context to understand how lenient an A or a green could be, or how much of a departure from the norm a B or yellow signify. As discussed in the overview of the data landscape, we would like to see more agencies using and reporting scores in the first place, but we also believe there's still a ways to go in improving how scores are defined and implemented. Okay, that's a lot of information to process. Can I answer any other questions at this point?
Yeah, Andrew Scott is asking if your company is an enhancement of products like HealthSpace or Inspect to Go or a competitor.
I would say we're a little bit of both. We actually rely on some of these vendors to help furnish the digital publication of inspection data. So in that regard, we actually see them as partners, and they're really vital to promoting this healthy ecosystem of rapidly churned out digital data. That's a big net benefit to the industry and for technology vendors like us. We may be considered a competitor in some senses where we overlap, if they are providing statistics, summaries, trends, any other information that helps guide further decision making. If it comes to just reporting, being able to host reports or providing the intake mechanisms for these reports. That's not an area that Hazel covers right now. We're really focused on the downstream effects of that, producing dashboards for customers, operational tools that they can use. That's really where more of our interest lies. So it's not quite a black and white answer there. It's a little bit of both stuff.
Yeah. And there's another question here. What is the advantage in using artificial intelligence in this process?
Well, that's actually a really great question. Some of the types of technologies that we're using, or I should say, some of the solutions that we're providing really would be much more difficult without using machine learning techniques. I alluded to our ability to harmonize against the food codes model inspection form in order to evaluate violations. And it's that ability to standardize and ability to predict that is really making some major headway in this field. To focus on violations, if we were to look at violation types just locally, you could have as few as 20 some odd types in a given jurisdiction. And that, of course, can evolve as the local food code evolves. We've seen upwards of 60 different types. They come in all kinds of different phrasings. The alphanumeric codes are different. So there's a big push to be able to compare apples to apples a little bit better. And that's where machine learning and AI technologies are really helping. I'd say more so machine learning on this front. A little bit further in, I'll have a mention of AI technologies as well.
And Andrew, another question. Do you think it would help if the FDA provided a model scoring system or rubric like they do in the model food code?
Well, that's a really insightful question. I think it could help. And I think that there's a lot of smart people working on this problem. So having some centralized, standardized guidance to reflect the best that we know today would certainly be helpful. But as we also know, the adoption of different food codes is also a bit of a patchwork quilt by state. The different versions that you may have adopted, the extent to which you differ from those models varies. I wouldn't be surprised if the publication of a national level scoring guidance would go some distance, but not the full distance. It's also a local concern. If there's an established scoring model that already exists and that your consumers, your general public and your businesses are really happy with, then making that change just to standardize could be seen as a step backwards in some regard. It's not an easy question to answer of how should we move forward.
Absolutely. And some of that is done, right, like you mentioned, at a local level, and some of those, the criteria was different per jurisdiction, which you noted in that other slide as well. Mary had another question. The information showed does not align with the FDA data on the 5 major risk factors for foodborne illness. And what are your thoughts?
That's a great observation. I think that what we're looking at here in part is a discrepancy between data that's published digitally online and the complete picture of everything that's getting aggregated up to the FDA. And I took this into account when I was building this. I really wanted to represent what the digital data landscape looks like, because that's by and large what we're working with on the industry and technology side. If we end up making decisions based on an incomplete or inaccurate perspective, that's a problem. We want to have the most accurate and complete data set that we can. And for reasons mentioned earlier, public records requests, non-scalable ways of accessing this data can really make the difference between whether or not something is going to take off in the industry. So I would love for everyone here to have this as one really key takeaway. Digital data publication is what we need for not just regulatory stakeholders to succeed, but really all stakeholders in our view. And that's a good segue to moving on to this next question. Elizabeth, I see your question. I'll try to circle back to that at the end. As regards the digital data landscape, publishing reports online is the new norm. If your governing agency isn't on board with this idea yet, you're missing significant opportunities to engage many stakeholders and potentially reduce costs in the long run. Timeliness, completeness, and quality of digital reporting are limiting factors for the types of analyses that we presented today. So the next frontier is moving beyond basic reporting and to push for the best reporting possible. We don't expect agencies across the country to completely align and standardize, but it is important to recognize that variations across jurisdictions do pose challenges for the industry. In the corporate world, there's some reluctance to roll out new policies or processes when it's not possible to readily assess relevant data points in some jurisdictions. If there's any metric that's less than 100% usable, it won't fly. It becomes a question of fairness in their corporate hierarchy. So improvements in digital reporting, making more data points available more consistently, more quickly, can translate into better industry self-regulation in a very real sense. Whether we're considering corporate food quality teams who pursue systemic improvements in their brand locations, or food delivery services who need to verify restaurant legitimacy and suspend delivery during mandated closures, or review websites who want to publish health inspection details for consumer information. The current data landscape can be difficult for industry stakeholders to use constructively. I would encourage the regulatory community to consider the ideas discussed today when evaluating which processes or technology can be improved in order to make inspection programs more useful to a mix of stakeholder groups with an interest in consumer safety. If your agency is looking for guidance, I'd encourage you to visit the research section of our website and follow the link to our white paper, Health Department Data Publication, Best Practices for Amplifying the Impact of Food Service and Retail Inspections, which covers very specific implementation details for better reporting. And I would challenge you to find one thing to improve in your agency's reports and to become a champion for it in your organization. I don't expect this to entail massive system overhauls in most cases, but rather a committed effort to diligently pursuing several smaller changes in tandem. We've also discussed performance indicators, such as scoring and violation details. At Hazel, we believe that environmental health agencies can and should use these simple indicators to send effective messages, especially for the consumer audience. Food safety is only one facet of consumer choice, so it's important to show something quick, informative, and intuitive. But as we've seen, there are some pitfalls for scoring. Letter grades can be subject to grade inflation, which weakens the signal of a top score, while numeric scores can suffer from a lack of context. The shades of gray below a perfect score may not be as impactful as a designer. We do have some reservations about the omission of inspection scores in reports. It may appease businesses who feel that the surprise or snapshot nature of an inspection is unfair, but the absence of a score may leave an information vacuum, which will be filled by voices less qualified to speak to food safety matters. So instead of removing scores, we would encourage you to consider ways to make scoring fairer for all stakeholders. The other indicator, violation line item data, is extremely important to industry stakeholders. The more detailed those findings are, the better that corporate teams can support their store managers in resolving issues and minimizing sequences of re-inspections. And the better that we can obtain a nuanced understanding of food safety trends nationwide, which serves not only the industry, but also public policy development. And I think this goes back to the earlier question around discrepancies between the FDA's published stats and what we're seeing through digital data collection. Violation details are also tied to areas of technological innovation. I've already mentioned our machine learning model for food code harmonization. We've also been onboarding customers to use our new corrective action management solution, which facilitates rapid communication and transparency between corporate teams and store operators to promote fast and consistent remediation of inspection findings. To the person who was asking about how AI technologies help, this is a perfect example of that. Without actionable violation details to support this type of AI-based workflow, the type of tool that we're seeing here wouldn't be feasible or would be much less. Finally, looking at the path ahead, I was really struck by several passages when I read the FDA's New Era of Smarter Food Safety Blueprint document, which I've excerpted a bit of here. Develop processes to analyze big data that could be used by the public and private sectors to strengthen predictive capabilities and make more informed risk management decisions. Engage new partners in a broad coalition, including technology companies. Explore methods to create large volumes of data generated by industry that can be accessed for analytical work. Speaking for a company that worked with big data, performs analysis, and works on predictive capabilities and risk management tools, I couldn't agree more with these recommendations. I hope that those of you in the regulatory and policy sectors see tech companies like ours as ready and willing partners. We would welcome your input on the hard problems that need solutions, especially where AI and machine learning may be applicable. We can accomplish much more, much faster when we have partners that are willing to provide early design feedback or support pilot studies. Keep the lines of communication open and keep the data flowing, please. There's one other passage from the blueprint that really resonated with me regarding predictive analytics. Expand the use of artificial intelligence and machine learning tools. Increase the amount and quality of data through the expanded use of information sharing agreements among various stakeholders. Again, I wholeheartedly agree. From what we're seeing, our customers in the industry are increasingly adopting or open to adopting tools that rely on machine learning technology. And the successes of these initial applications of ML or AI technology will beget greater adoption and greater demand. In addition to the harmonization that I've already mentioned, we're now launching a pilot with 3 of our customers, restaurant brands, for a workflow designed to predict the facilities most at risk for a critical violation in their next routine inspection. That also provides context on each facility's current performance and recent performance, and raise awareness with key stakeholders who can take direct action. This effort is based on another purpose-built machine learning model that we've developed for exactly this AI system. One of the key takeaways for applying this type of technology is that the problem to be solved is often one of prioritizing attention and resources, and major improvements can be made even without perfect classification or perfect prediction. For an example not originating from my company, I would point to the Finder model, which was a collaboration from teams at Google and Harvard that aimed to use search and geolocation data from consumers to identify restaurants with potential food safety violations that could be actively causing foodborne illness. In a mature application, the machine learning component can automate the most clear-cut decisions while also flagging the cases where it can't make a strong determination, allowing humans to step in and make the harder judgment calls. This approach can provide the best of both worlds, reducing labor to a significant extent while minimizing the risk of impacts from incorrect automated decisions. Combining a data-rich context, a proactive emphasis, and machine learning technology, I see AI as having the potential to amplify the voice of environmental health agencies and other stakeholders working to improve food safety. At Hazel, we've discussed the potential of sending a message like this to every food service or retail operator. Your facility will be visited soon for a routine inspection, probably in the next 2 to 8 weeks. In your last routine inspection, there were 4 violations, including 1 designated as priority. This result was a little bit worse than average. And then there's a link to recommendations on avoiding repeat violations, jurisdiction-related stats, and so forth. This closes with a call to action to encourage the recipient and remind them that full compliance is within reach. By and large, the data needed to produce this kind of message is available. And with the help of the regulatory community, data availability should improve over time. The next big challenge will be finding partners who are willing to adapt and able to deploy new systems. So If you're interested in having a role in the development and oversight of new and exciting technologies like this, I would encourage you to reach out to us or to other industry and technology stakeholders. Help us understand your issues, your concerns, your goals, and work with us to realize the potential of big data, machine learning, and AI for better food safety. Thank you so much for your time.
Thank you, Andrew. We do have time for a few quick questions here. Elizabeth asked, do you have any data on what the public prefers in our reports? A percentage score, a categorical, or letter grade score?
No, I don't have that. That's a really interesting question to pose. Based on what I saw for just what reporting jurisdictions are using, it seems like letter grades are very popular. And that could just be an artifact of how several of the early inspection scoring systems were letter grade based, as well as people's familiarity from coming up through school. But in terms of preference, I don't know anything in particular about that. If you find anything out, I'd love to know.
Okay, we have a couple comments. James said, without using risk-based inspection methods and following report marking instructions, the scoring system will be flawed. I think other pieces are needed to be in place along with the scoring system. And scoring and grading at a national level will not be feasible because of political scenarios at each local level. Just my take. Thank you. Mary asked, how does the data gathering differ from data mining? How is predictive modeling being used?
To an extent, I feel like these may be the same terms. I think I see what you're driving at, though. Mining the data is perhaps in large part a matter of asking the right questions of the data. Today, I was able to take us on a bit of a dive through 4 questions. One of the ones that I didn't get to include today that I would love to dive deeper into is actually on reinspection performance and how often reinspections are completely successful versus how many times a further follow-up visit is needed. It's really looking at the different facets of the data, understanding what can and can't be well standardized, and coming up with the measurements that make the most sense. You may have noticed that I used a lot of medians for this presentation. In many cases, we find that that's the best representation rather than averages, which can be wildly skewed. We have had similar issues when looking at scoring, where a really remarkable percent of inspections might have perfect scores. And if you try to just stack rank inspections, or if you take a naive approach to standardizing inspection scoring, then those more heavily weighted categories can really create issues. If there's another aspect to data mining that you'd like to discuss, please feel free to get in touch with me. I see a question about whether the presentation is posted on the website. I know a recording will be posted, and I believe after this, I'll be able to attach a copy of the presentation to this talk landing page. So I'll do my best to make sure that you get a copy of this. If for whatever reason you can't find what you're looking for, you can please feel free to reach out to hello@hazelanalytics.com or to me personally, Andrew@hazelanalytics.com.
Thank you so much, Andrew. Thank everyone for attending today. Feel free to continue the conversation in chat on the Pathable platform, which is not on Zoom. It's the other platform that you were on when you logged in. And Andrew would be available to continue that chat. Thank you all and have a great afternoon.
Cheers, everybody.